alternated angles. So we're looking at the third relationship here. I didn't mention in the previous videos, but make sure if you look in your notes, I'm going to go back just to make sure that in your notes you're following the same numbering. Do you see that I use here the subtitle was 4, and in subtitle 4 I was talking about the spatial relationships between angles formed between two parallel lines and transversal. Within that subtitle 4 then comes 4.1, that is the one of vertical opposite angles, and also comes 4.2, that is correspondent angles, and also comes 4.3, that is the one that we're talking about now, that is alternate angles. Okay, so alternate angles are angles that are positioned between the parallel lines. So I have parallel lines here, so they're going to be between the parallel lines and on alternate sides of the transversal. So it's going to be here and here. These ones are called alternate angles, and alternate angles are also equal in size. So here we come with, why do we call it AZ? So this is how you're going to remember, because you're going to be drawing a Z. So look at here. And I just created this angle and this angle, which are going to measure the same. Remember to highlight that they're going to measure and going to be equal in size. So angles that are positioned between the parallel lines, so they are between the parallel lines, and on alternate sides of the transversals. So this one is to the left and this one is to the right, therefore they're going to be the alternate angles and they're going to measure the same. So if we look at the diagram here, we can see here the two types of sets that I can have, the one that I drew or reflected to the other side. Then you can see the other two angles that are alternate angles. Wonderful. Please copy this in your notes. Okay, the fourth relationship that we're going to study, so this one is 4.4, is still talking about those spatial relationships, are called cointerior angles. And when we're going to talk about cointerior angles, I want you to remember by doing a C like this, okay? That's going to be how you're going to remember cointerior angles. Angles that are positioned between the parallel lines. So again, they're going to be between the parallel lines. And on the same side of the transversal, I'll call cointerior angles. But these ones, they don't measure the same. The cointerior angles are supplementary, therefore they add up to 180 degrees. So please highlight with a different color. Notice that here I'm highlighting this one with green and not with yellow as I did before. Wonderful. And as I said, we're going to form a C for these ones. So if I have here and here and here, we can see that I have this angle here and this angle in here. Notice that I'm not using the same symbol. This one is a dot and this one is a X. And the reason why I'm not using the same symbol is because they don't measure the same. They are supplementary and they're going to add up to 180 degrees. So in your notes, where am I? Here. So your dot plus your X has to be equal to 180 degrees, okay? Because they are supplementary. Wonderful. Let's look at, here's the same example of what I had before, but you can see that we could also, and I don't know why I didn't have it here, but we could also form the opposite in here, like reflected. And then I'll have this angle with my dot and this angle with the X and this pair will be supplementary, so they will add up to 180 degrees. Please draw this in your notes. Okay, let's do a summary of what we have achieved so far. So there are 4 relationships. 4.5 is the summary, okay? So first we spoke about vertically opposite angles. And if we have labeled all the angles with a pronumeral, we can say that A and C are equal, and B and D are equal, and F and H are equal, and E and G are equal because they're vertically opposite angles. Okay, I want you to draw this as a summary in your notes. Additionally, if we think about alternate angles, then we have that C and E are equal, but also D and F will be equal if we draw this set like this. Wonderful. I will highlight it what I said. If I draw it like this, then I can see that D and F are equal because they are alternate angles. Now, if I drew all my F's as the one that we have here, I can see that C and G, I'm going to highlight them, C and G are corresponding angles. And then D and H are corresponding angles, and therefore they measure the same. And then B and F are also corresponding angles, therefore they measure the same. And lastly, we have A and E, which are also corresponding angles, therefore they measure the same. Good. Maybe it's a good idea to do exactly the same thing in here. Use colors to symbolize how you're doing this one. So I'm going to use the yellow one for D and F, and then I'm going to use pink one because I don't have red yet, C and E, to symbolize C and E. Perfect, with this set that I have in here. Great. And if we use here, then we have that firstly A and C are vertically opposite angles, and then B and D are vertically opposite angles, and then F and H are vertical opposite angles, and finally E and G are vertically opposite angles, and therefore they measure the same. Wonderful. Let's continue here with our notes. Lastly, cointerior angles, where I have that C plus F, because they form this C in here. They're going to add up to 180 degrees because they're supplementary. And then we have D and E, D and E, which are also supplementary. Okay, girls, so just notice that we're going to do 5, so I'm not talking again of those relationships. I'm outside. I'm talking about a different subtopic that is number 5, okay? And this one is about testing for parallel lines. So if 2 lines and a transversal intersect to form any of the following angles: a corresponding angle, or alternative angle or cointerior angles, then the two lines are parallel. So that's why what we have been learning is very useful, because it helps us to prove if two parallel lines are going to be parallel. Because sometimes lines can look parallel, but if we extend them to infinity, then they eventually will intersect. So instead of having to waste a lot of paper in extending those lines forever, if we measure the angles that they're forming with a transversal and see if they're forming either a corresponding angle, an alternate angle, or a cointerior angle, then we will know that they will be a parallel line. So let's look at an example of what I'm talking about. So we have here two lines, okay? The two yellow lines, A, B, and C, D. Agree? And they look quite parallel. Do you agree? We have our transversal in green here, and the people that have drawn this have measured for these two angles. So they have here this one that is 70 degrees and this one which is 105. So if these two lines were parallel, these will be co-interior angles. Do you agree with me? So these will have to be co-interior angles. And if there are co-interior angles, then they will have to add up to 180. They will have to be supplementary. And then when I see here, I can see that 105 plus 70 is equal to 175 degrees, which is not equal to 180. Therefore, these two lines are not parallels. Are not parallel. Okay, wonderful. The last bit of theory that we need to do today is about perpendicular lines. So we finished this. That is our subtopic 6. And then we will do some examples. So perpendicular actually means at right angles. So when two line segments meet at right angles, they are said to be perpendicular. And the symbol that we use is this one that we have here to symbolize that they're perpendicular. So we see here that we have the line AB, which is forming a right angle with the line OX. And we know this because we have our symbol here to symbolize that we have a perfect right angle here. So therefore, AB is going to be perpendicular to OX. Wonderful. Please copy all this in your notes, including the drawing.